All right, hello everyone. This is Mr. Crozier. I'm going to give you all the answers and work for the practice test. 2.67, here we go. Solve the inequality. Well, we're going to subtract this over to here, factor it, and then we're going to test points. And we're going to pick a point in here in this interval. Maybe I pick 0. And if I put 0 in here, I have a positive times a positive. It's a positive. If I pick a point in here, -5, I have a negative and a positive. So we have some sections that have positive numbers. We have some section that have negative numbers, and we're looking for the positive numbers, the numbers greater than 0. All right, horizontal asymptotes. Always remember what that is. That means what is the graph doing at infinity? Well, in this case, if I just look at the front end behavior, I'm going to get it down to this. I can divide away the x's, and I have 3 over x and 3 over infinity. Well, what's that going to be? If I have 3 divided up infinitely, an infinite number of times, every time I divide it, it gets smaller and smaller. So it's going to 0. Slant asymptotes are long division. This is your slant asymptote. You can ignore the remainder. That's your asymptote. Here, rational function. Set it equal to 0. Multiply it over, factor the top, and we have 0 and 5. Now, don't consider -2 or 2 part of this solution set down here. 2 would be down here. However, it's a whole, so I'm going to get rid of it. Same thing on here. Factor it, and again, your critical points are the zeros and the 0 up here. But these are also critical points too. Wherever it's undefined are critical points. Again, domain. Asymptotes are when they don't go away. Holes are when they go away. And I get this question a lot. We know there's a hole at 3, so it's here and here. The question is, how do you get the y value? Well, you plug it into what's left. Whatever's left after you remove the hole, these two values are gone. So we just have x plus 4 over 2. If you plug 3 into that, you will get the value. What value would it have a hole? Where do we want them to match? We want this to match down here. So I had 2x plus 1. I wanted it to be x plus b. If I divide this by 2, now it's x plus 1/2. So there's your hole. And over here it's a little bit easier. X minus 5 needs to be x plus b, so it's just a -5. On the second page, you're never going to cross a vertical asymptote. It will never cross the vertical. But sometimes when we have horizontal ones, it will cross. It will cross. It will get closer to it, but it will cross. Again, holes and asymptotes. Factor it. Write your new equation. What is this on a chart? Well, if they're coming together, it's a hole. If they're going apart, it's an asymptote. The domain, all real numbers, but positive and negative too, because I set this denominator can't be equal to 4. After I set it to 0, I move that over there and it can't be 4. So x can't be plus or minus 2. It can be written like this. That is set notation. This is interval notation. On number 13. As we go to 5, well, there's nothing at 5. But on the right side of 5, it goes to negative infinity. And on the left side of 5, it goes to positive infinity. So this means right, this means left. But at negative infinity, the output is -5. At positive infinity, it's also -5. What does it mean for horizontal asymptote to have one be 0? Well, that means the denominator is larger than the numerator. So we want this d power to be greater than the 5 up there. So the answer is, well, when d is greater than 5. But more specifically, we can't have all numbers because we don't want decimals. So we just say all integers. So that's why when you see the answer key, it's going to have the letter Z there for integers, meaning no fractions. And upside down A can be all integers. D is greater than 5. So it doesn't have to be just not all real numbers. We don't want real numbers. We don't want decimals up there. When does it have a slant asymptote? Well, when the numerator is 1 higher than the denominator. Again, it's a big part of the test. What happens at infinity? Well, just look at the leading term. This is going closer to 1/3. X and Y intercepts. X, plug in X. Here, if I plug in X, I'm going to divide by 0, right? If I plug in 0 for X, I'm going to get -3 over 0. That's undefined. But if I plug in 0 for Y, I can solve that equation because then I have 0 equals 2x minus 3. But you always want to take out the holes first. If there are holes, take them out, and then the math's a lot easier. Inequality problem. Move it over, factor it. Factored by grouping here. And then I got down to my critical points, then test them out. Same thing here. Don't forget, these are critical points, 4s and 5s. 4s and 5s, and a 0. Rational function again, same thing. Factor it. Look for these difference of squares. X plus 4, x minus 4. Population, limiting size. If I were to graph the bear population, it's going to start, but then it's going to limit at 200. It doesn't go above 200. And you can see that by just doing the front end division problem, 60 divided by 0.3. Solve the inequality again. I moved it over. Then I did some factor by grouping, and it did work. So I got here. And again, always be on the lookout for those factorings, and you'll have that answer. Rational function. 3 critical points, or 1, 2, 3, 4 critical points. 1, 2, 3, 4 critical points. On the last page, here we go. Population here. Initial population means how many fish are there on day 0. When the graph starts, when I graph this population, day 0, there are 10 fish. The fish are going to grow, but they can't grow forever. There is some limit. And if you look at the limit here, the limit is 5,750 fish. All right, we have a graph. What's the domain? All real numbers, right? All real numbers such that x is not -1 and x is not 2. We have 2 asymptotes there. Well, set notation, interval notation. What is f of -1? At -1, it's undefined. What is f of 1? Well, at 1, I do have a point there. There's a point, it's about 1, 5, and f of 3 is about 0. At infinity, where is this graph going? Well, if I look over here, we can assume that there's an asymptote right there. What about 2? Well, 2 is right here. There is nothing at 2, but on the left of 2, it's at infinity. And 0, well, 0, there is a value at 0. So on the right side of 0, it is also going to 3. So when there is a value there, it makes these very easy to do. What are the zeros? Well, that's where it crosses -2 and 3. Consider the graph below. Negative infinity. There's an asymptote at 1. 5 from the left-hand side. Well, 5 from the left-hand side, I can't read my graph very well, but it comes to be about 4. And 4 from the right-hand side, right here, well, that's going to be up at infinity. All right, what do we have in the table? Well, f of 3.99. Well, that's that value right here. Should be negative. It's that number right there. What is f of 4? Undefined. And where is this graph going? If we go to 4, here's 4 from the right side. Numbers that are, if we drew 4 here, we went on this side, on the bigger side. So where are these numbers going? Well, look at those numbers. They're getting bigger, bigger, and bigger. I think they're going to infinity. All right. What's C of 5? Well, when you do 5 tanks, it's going to cost $30,000. You just input 5. What is the limit? Well, if they make an infinite number, I just look at the front end, 25,000. Average rate of change from 0 to 5. On 0, it's 30. Also on 5, it's 30. 30 minus 30 is 0 over 5. All right, I hope this helps with your test tomorrow.